Hello and welcome back, it's MGL here. We are still continuing with the cold water systems, but this time we're going to be looking at learner outcome 1.6. Remember, if you do find this video helpful, remember to drop a like, leave a comment and even hit the subscribe button to help support the channel. Right, so by the end of this video or session, learners will be able to identify mains water services to the property and isolation points, connection methods to the mains, communication pipe details, service pipe details, mains external stop taps, locations and meter housings, installation requirements and methods of entry to the service pipe to the property. So there's lots of little bits on this one, so so please, enjoy. So let's have a look at the first one, connection methods to the mains. Right, so mains are the mains that are in the street. So we've got to connect your supply to your property, your dwelling, to the mains in the streets. Now, we don't do this as plumbers unless you work for the water undertakers. So the water undertakers are the people that tend to do this, not us. But we need to be aware of how to do it just in case we have any problems. So, or we might need to do it ourselves. Now, we connect these with a ferrule. The ferrule is a type of shut-off valve that is connected to the mains. So we can isolate the supply from the mains if needed to do repairs. And this is another tap. So don't think it's your main stop tap that could be located in the street. I'm going to go through all this in a minute. But the ferrule is another means of isolation for the undertaker, mainly if they want to do some more work. Right. Now this ferrule has to be cut into the pipework. Now bear in mind this pipework, this mains pipework that's in the road is under pressure, so you have to do this live, and this is why the undertaker does it as well. But because this is done live, they have special machinery that does it and helps them for them. So here's what the ferrule looks like. This is the bit that's going to be put into the pipework. It could be into plastic pipework or iron pipework. It's very unique on its design, so it can be put in to anything. Another version that we can come across is this version here. So this is another ferrule design. This one is designed for plastic pipes, whilst the ferrule on the right is for the cast iron pipeworks or metal pipework that's still used in the roads, but everything's getting changed now to plastic, so this tends to be these ones here. Now the machine that they can use is this one here. It looks fairly complicated, doesn't it? And it is an art form to use. I've seen it being used a few times. It scares the bejeebers out of me because once it goes through, you hear the pop and the mains water pressure hit that unit. But you don't get wet sometimes. You get a little wet sometimes. But it's a lovely piece of kit. And they have them for various diameters of pipework. Whilst the newer system, here we go, got my little pointer here. These are usually all built in for themselves. So the next slide, this is the link to a video that shows you what this is. I will put the link in the description below. And it shows you how we do it with pipework or plastic pipework now in the UK. When you get there, you will see that it's this pipe company. So GPS PE pipe system. So they're the ones that have designed this system. And this lovely little video, it's a very short video, will show you how they do it. So I do recommend watching it. Right, distribution. So we're now going to get all this pipe water to where we need to get it to go to. There's two ways of doing this. So the first way is gravity. This is where we let the water do its own thing. So collecting upland surface water is impounded in a reservoir at high grounds. Here the water is filtered, slow sand filtered and chlorinated before being fed to homes, factories by gravity. No pumps required. This is how we used to do it beforehand. So we didn't really put any pumps on this system. So here you go, nice little picture for you. There's our reservoir. It would come in here. The slow sand filter would then filter this out. These could be quite large pounds. Then that water comes out the bottom, goes into a service reservoir. This has got a lid on it. It is all sealed, so no more contaminants can get in there. and then it is chlorinated with the chlorination house. Now these test how much chlorine it needs to put in, and then the mains is basically just gravity fed down the hill until it gets to where it needs to go. So the higher up it is, the more pressure you have. The lower it is, the less pressure you have. Now, we changed that though, because, you know, we don't always have this opportunity. I'm going to move my little pointer. We don't always have the opportunity to have the water stored high. So we went to pumped. Now, pumped is just a similar process, but we pump them up to a high tank to then let them drop down and go to where it needs to. And then we use a second pump to pump it to wherever we've got to send it to, usually to rivers or systems. So water is taken from the river. Water is taken from the river, is pumped to the settlement tank. We let it do its thing. All the impurities sink to the bottom. We then pass it through a slow sand filter. We then pump it up and chlorinate it all at the same time up to a storage tower. And then we let it go off to where it needs to go by a gravity. So here it is here. So we can use this method here. But again, this is an old method of doing it. So we take the water from the river, we pump there, we sediment tank there, we slow sand filter there, then we chlorinate it and pump it up to this storage system up here, and then we go off to the mains and let its gravity do this duty. But the more modern way is that we just bypass the tower and we use pumps now to pump that water to wherever we need it to go to along the mains. But there are still some areas within the UK where that pressure isn't good enough during the day. So they still have water towers near various places where the water is pumped up to the top of the tower at night, and then that water then supplies the small village in the middle of nowhere with pressured water. It's a very old system of doing it, but it is still used to this day. So that's that one. So we've got pumped and we've got gravity. Now, cold water systems to the property is known as a trunk main. The trunk main varies in diameter depending on the purpose of the main. So this is coming from the water supply company, the water undertakers. This pipework is sized to supply water at various rates. So the diameter could go from 75 mil up to 2.3 meters in diameter. That is a big pipe. I've only ever seen one of them. And it did a lot of damage because that one had burst. That's why I could see it, because the water undertakers turned up. They sorted out the leak and then repaired it, and I could just see the pipe work once they'd repaired it, and then they recovered it all back over. That is a big pipe though, at 2.3 meters. The size of water mains determines the size of the community that it is serving. So here's like what I'm on about here. So here, get me pointer. Here's the trunk main coming from the treatment plant. The best way of describing this is, think of it like a tree. So this is your trunk main. These are your branches, yeah, and they go off to the various properties to suit the needs. So houses and other buildings. But when I was saying before, it depends on the size of pipework. So if we have a town or population of 500,000, we'd use 1.5 to 1.2 meters in diameter. 2,000 properties, 0.75. For 5,000 to 20,000, we do 0.2 to 0.3 meters pipework. So you get a general gist of how many people can supply. But imagine how many people could be supplied to 2.3 meter pipework. Yeah, we're talking cities for that kind of pipework. So at some point that's going to be there around there. Right, now, cold water to the properties. Ignore stop tap. Something has gone wrong somewhere along the lines. I don't know. But ignore stop tap down there. So water services to the property. So these water services, we send the pipework to the properties, and it comprises of two separate pipes. So you've got the communication pipe, so you've got the trunk, then you've got the branches, then you've got the communication pipe, owned and maintained by the water company. Then you've got the service pipe work, which then comes off and owned and maintained by the owner of the building. So There's certain bits that we have to remember, where it starts, where it doesn't start. So now you'll see where this stop tap will appear in a minute. I don't know why that didn't do what it's supposed to do. So the service main is here. This comes into this point here. This is your meter or your boundary isolation. Okay, so that is what the water company owns. So that's our communication pipework. This is where the ferrule would be located on this pipework here. Then it goes to this bit here. Now the water undertaker basically owns up to that wall. Yeah? So that belongs to the water undertaker. Then the service pipework is from your boundary wall all the way into the property to the stop tap. That's what that stop tap's there for. It's for that point there. And then that goes up into your house and does whatever it needs to do. Now, there's some other key details I've purposely put on this drawing. Depth of the pipework. It should be no less than 750 mil deep or no more than 1,350 millimeters deep maximum. So that pipework has to be within that golden zone. If it's not deep enough, the weather will affect the water supply. So say we buried this 500 mil down. On a hot sunny's day, you will notice your mains water will first come out of that tap hot. It is not nice. There is risk of bacterial growth. There's all sorts of things that can go wrong with that one. If it's in this golden zone, the weather doesn't affect it. There's also the risk, though, that on a winter's day, it could freeze your water main overnight and then you've got no water and it could be burst underground and you lose a lot of water. Then we've got the maximum. If we go down again too far, we start picking up the heat from the ground and the water breaches certain temperatures. So again, we've got to hit that golden zone. I always used to dig mine down a meter. I had a shovel that was a meter long, so when I dug down, it would get, when the shovel handle was level with the ground, it was perfect depth. And I'd move my way along and keep going that way, and I knew I had the right depth every single time. Now when it comes into the property, we have a 75 millimeter service duct, sealed at both ends, and no other services must go in there. These are usually also insulated. Because again, as we come up through the floor, we have that risk of cold weather freezing that pipework here and coming through the wall and freezing. So we also insulate that service duct. I hope that makes sense. Again, one of my recommendations would be for it, pause the video, draw that out, move me stop tap sign over a little bit and just memorize what that is, or find it in your City and Guilds book, label the page important. Okay, right, so we continue. Most water supplies in modern dwellings and industrial premises are piped in medium density polyurethane. I've hopefully said that right. I'm not 100% certain. Or otherwise known as MDPE. This is what everybody else calls it. This is what plumbers call it. We don't bother with the big long words. We just call it MDPE. Its colour is blue. This is to indicate that it is for wholesome water. The minimum pipe size for modern dwellings is 25 millimeters. Soft copper pipes conforming to BSEN 1057, or otherwise known as, it used to be known as R220, may also be used. This is copper pipe that is specifically designed to go underground. So R220. We don't use this inside properties though, so please don't go order that and think, oh, I can use it inside a property. We don't. It's R250 that we use for inside a property. Right, so here we go. So this boundary we got here, this is our boundary valves. So up to the wall, this all belongs to, this all belongs to the undertaker. They can also tee into your service pipe there, but then it goes off to wherever it needs to go to for its various jobs. The pipework should then be sized accordingly to supply of water to that properties to meet their demands. I have made a video already on how to pipe size cold water mains and pipework inside the property. If you're interested, please go and find that video and have a look at it. It's something that comes on later on in phase 2 and phase 3, but I've left it in there because this is another problem that some of my students were having, was how to work out how to size pipe. Right, so meters. This is something you're going to come across a lot more often. The water undertakers now are installing meters for every new property. They're also installing them in the streets for older properties or inside the property itself. They usually ask for permission to put it inside the house, but if they get told no, they'll put it outside of the house. With new installations, a water meter is either fitted at the boundary to the property or external stop valve chamber, or external groundbreaking type meter box on the side of the property, or they can be located inside the property. So this one here that I'm showing you there, this tends to be internal. This you can find under kitchen sinks or wherever the main comes in. It could be in a cupboard anywhere. Mine in my property is under the kitchen sink. So we've got all the various parts. There's the meter. We've got a stop valve there and a stop valve there. We have these to isolate so they can do work on the meter if they've got any problems. This meter is usually made out of a plastic, so we lose our continuity of the pipework. So we put this earth bonding or permanent cross bonding so we maintain the earth point for our pipework. All our pipework must be earthed going into a property, so if there's any problem, so say a wire touches that pipework, it will go to the earth. And then we've got a drain valve there, always on our pipework, so we can drain the installation as required, so we can carry on with our work. Right, next one. Here's one of these groundbreaking meter boxes. It's basically a giant insulated box, so we can put the pipework on the outside of a customer's property. There's the meter, there's the isolation, and these just clip in. But they're so well insulated, none of the pipework will freeze. It is a lovely system. I do like it a lot, and it makes life a little easier for us plumbers as well. So if we're having problems inside the property, we can just go there. We don't need any special tools to turn the water off in this mains. We can just reach in and turn it off by hand. So much easier. And then the last one, this tends to be the one that's on the outside of the boundary. So this is usually located underground up to that level there. These are adjustable for the various depths between 750 and 1350. So they are adjustable. So there's your blue MDPE. It comes in. This mechanism here is inside here already, and then it comes out and goes to the property. This is your pop-off cap. So you might need a long rod to reach down to turn the mains off as required. Okay, so I hope this helps on that one and your understandings of the various ways that we can have a meter. Now, when the valve comes into the property, remember we said it should be a 75mm duct. It should be sealed at either end and insulated. Well, here is, I'm sorry, this is the best picture I could find for this. Here is the blue pipe coming up into the property. There is my main stop tap. So, as far for responsibility principles, right? A stop valve should be located inside the building so a customer can isolate in emergencies. Be located above the floor level because, again, customers do not want to be lifting up caps, fighting with spiders and trying to put their hands in to turn the mains off. As near as possible to the point of where the water supply enters the building. So again, if there's any problems, we can quickly isolate it, but we won't cause many problems with the mains coming in. It should be installed that its closure will prevent the water from supplying to all joints or points of use or termination points inside that property. So you would do that, you turn it off, everything should be turned off. There should be no taps missed out or no outlets missed out. Sort of makes sense really, doesn't it? And then the last and the most important one, I would make a note. No more than 150mm of blue MDPE pipe should be exposed above that floor. The reason why we say this, or the way the rules are there, this pipe will degrade in sunlight. So one of the other rules that's in there, I should have put it in there, is this pipe should be installed somewhere where direct sunlight will not hit it. So this is why we usually put them in cupboards, underneath sinks, things like that, so that it cannot be hit with direct sunlight. because if it does get hit by direct sunlight, it will degrade over time, and then you end up with a lovely burst pipe that the customer cannot control, and they have to call someone out and they'll have to turn it off at the mains. Right, so I believe that is the end of this video. I hope you found it useful. Please remember though, if you've got any questions, leave them in the comments below. Either myself or someone else who understood what I'm talking about, or also a qualified plumber, may be able to answer it for you. I do answer as many comments as I can, but you've got to remember I am still a practicing plumber and I am also a teacher. So I am doing two jobs and sometimes I don't have the time. Okay, but I will answer you as soon as I can. Again, if you have found this video useful, please remember, drop a like, leave a comment, and even hit that subscribe and help support the channel. I really do appreciate all the support I'm getting so far. It's amazing. It's, as I say, it's something I never thought would happen. So thank you very much for your support. And again, thank you for watching, and I will catch you in the next video. But for now, bye-bye.